Hello everyone, I am Soumitra and I will be demonstrating an experiment that I have created in Microsoft Azure ML. So as you can see, I have already taken a data set. So let's quickly visualize this data set. And as you can see, this data set has 158 rows and 11 columns. So basically this data set is all about the happiness index of the citizen of these countries, and the parameters that this data set has is ladder, which is the measurement of life satisfaction, positive effect, which is the measurement of positive emotions, similarly negative effect, social support, freedom, corruption, generosity, and per capita income, and column 10. So column 10 is the measurement of life expectancy, and this is the column which I am going to actually predict through our data mining model, which I have already created in Azure ML. So let's get started. And as you can see in my model, I've already taken the summarized data, which summarizes the whole data, and which gives us the descriptive statistics. And then I have taken select columns in data set. So the columns that I have taken, which I will be using to predict the life expectancy of people from those countries, are ladder, positive effect, negative effects, social secure support, and the parameters that I have highlighted over here. So after this, I have actually split my data into two parts, which is the trained data set and the test data set. So I have split my data in like 80% of the data will be used for training the model, and 20% would be used for testing the model. The machine learning algorithm that I have used for training my model is linear regression. So as we all know, regression is a regression builds a relationship between two variables x and y. So basically, regression can be of two types, which is simple regression and multiple regression. The difference between both the regression is in simple regression, there can only be one independent variable, whereas like in our case there could be multiple independent variables which can be used for predicting the one dependent variable. So after training my data on linear regression, I am then scoring my model after the training. And as we can see in scoring of the model, the score label, which is then created by the test data set, and this is the estimate of the prediction that is created by the test data set. After this, we are evaluating the model, and then running this model. So I have already ran this model, and the model is now ready, and therefore we will now evaluate the results. And after visualizing the evaluate model, we are getting the metrics, which is the measurement or of the model, if the model is accurate or good enough to predict whatever uh, we are supposed to predict. So the matrix that here we have got are mean absolute error, root mean squared error, relative absolute error, and relative squared error. The two that I'm really interested in are relative absolute error and relative squared error. So basically, these two uh, parameters should be as low as possible. They follow like an inverse relationship with the goodness of the model. So as low as these two values are, the better our model would be. So as you can see, the values are really less, and it is near to it is 0.2, which is like really less. And the third, which is really important parameters that I'm interested in, is coefficient of determination. So 0.71. So this one follows like a direct relation with the goodness of the model. So as high this coefficient would be, the better our model would be in predicting our experiment and our results. So after this evaluation, then we are supposed to then set up the web services, which will then uh, provide us a predictive experiment. So here in predictive experiment, here I have already ran the predictive experiment, in which, as you can see, the web service input is then given as an input to score model. So here the random or the numbers or the data which we would be getting from web service input is then given to the score model. So here, after doing this and running this, we have got, and of course, I have excluded the column 10 data set from here, as we are going to predict this after deploying of the web services. So after deploying of the web services, we get this, and after executing the test final, I've already inputted my values here so as to get a quicker result, and we are getting these parameters that we selected as previously shown. So I have already inputted my values randomly over here, and after, as you can see, I have actually given a really less a positive effect, negative effect, social support, and I am high on corruption and and other so the prediction that our model should be generating should be of life expectancy, which should be less according to our data set. So let's see and go ahead and execute this test. So as we can see, the the parameters that we inputted provides an output of life expectancy, which is 26.07777, which is really less, and we can say that our model is predicting well. And secondly, I have already inputted here, again I have inputted some other values in which I am high on positive effects, social support, and freedom. Here our model should predict that our life expectancy should be high for all the other countries. So let's run this, and here it is. For all these parameters that we inputted, our life expectancy is near to 78, which is really high, and therefore we can consider this, or we can reckon this, that our model is working fine, and this model could be considered as good. So here I end my demonstration of my experiment in Microsoft Azure. Thank you.